Alright, I'm going to jump into photoelectric effect on Reddit, but before that I'll look into some images. Probably should images are a pretty good place to start first. I don't know if we're going to be dealing with metallic substances or if it's going to say, so here it says kinetic energy. So it can either deal at the atomic level with electrons, or some places are saying, well, it can only deal with metal, like metallic substances. So this says the energy of light equals minimum energy required to remove an electron from the surface of the material plus kinetic energy of photoelectron. So this is where it really gets into quantum mechanics, because you can't really. I don't know how you're going to be able to put a number on this. So yeah, let's check out some of these meanings. Photoelectric effect is the name given to the phenomenon whereby electrons are emitted from a metal when exposed to electromagnetic radiation of the appropriate frequency. I was talking about metals. Hyperphysics. Photoelectric effect, according to Einstein's theory, is a single photon collides with an electron in the metal, transferring all of its energy to the electron, thus liberating the photoelectron from the metal surface. So it's the same idea, but you're really just saying, well, there's an atomic surface. Instead of metal, there can just be an anatomical one made of atoms, the bits, the particles. But in my understanding, it all has to be quantized, just because, yeah, if you're going to animate it, it's not going to really give. You're just going to end up saying what Newton says, and Newton says that he doesn't understand gravity. So if you don't understand, if you're saying you don't understand gravity, well, you're saying you basically don't understand the polarization. You don't understand the magnetism. You don't understand the electricity, which is definitely the most fair thing to say. But if you go any further, then yes, it has to be quantized. And to do that mathematically, yeah, you have to have kinetic energy. You have to have an anti-gravity. Again, because something has to emit the gravity, something has to cause the gravity, and that object should be made of atoms. So I don't see why it's so disproportionate to have kinetic energy, thereby a mathematical formula to say, well, there's energy already being experienced. Because if you give something velocity in the past, if you give something more velocity from the past, then yeah, you can say that quantizes electrons. According to the quantum theory of light, it has a dual nature. It behaves both as wave. Wait, what am I doing here? According to the quantum theory of light, it has a dual nature. It behaves both as wave and particle. Okay, so this is like just wave-particle duality. This property of light is called dual nature of light, or wave-particle duality. Photoelectric means emission of electrons by light fall on metal surface. I would hypothesize that, well, what I would explain to people is that there is no speed of light, first of all. There is no speed of atoms, because I just think it's wrong to quantize. How do I get into this? Go right here. I just think it's wrong to quantize. Like, see, if you go into here, right, so these are all photons. Photons crash. This is technically, all right, the photons are colliding with this surface right here, where my pointer is, and these are electrons, and then these electrons, there's going to be some electrons that leave this area. I don't know if that which way, probably doesn't matter which way they go. And so I'm just saying that there is a good reason not to. Einstein didn't believe. I don't believe that Einstein thought that it was a good idea to quantize photons. That is to computerize them. That is to give them numbers. That is to give them binary code. Obviously, kinetic energy gives binary code to everything. And that's why they can't quantize gravity, because gravity has to have basically that Lorentz force. It has to have that right hand rule of electricity, magnetism, and force, if you will, and that can exist in any object in the universe, and that's why it's not quantizable. That's why you can't quantize gravity. So they have to talk about gravitational waves. But yeah, I'm just saying it's not smart to even quantize photons, because if you have these effects, if you have these distributions between the photons, see, they call them rays. So that means that there has to be it has to be made up of little bits. I don't really agree with that. I think they should be um, their own line of particles, because yeah, we're not really even seeing rays anyway. Um, I guess a good question is like, what do you say a fire is made out of? A fire is made out of. It could technically be made out of photons, I suppose. Except, yeah, why don't you just have a photoelectric effect with atoms uh, moving at high energy to make up the photons? So that's why I just don't agree with quantizing. And it seems like in almost every physics formula or equation, they're not even quantizing um, light. The only time they quantize light is when they use it as a distance, like a measurable, like 1 light year, 2 light year, 3 light year. And my problem with that is it's always in the past, because they are testing the Big Bang, which is just a horrible resolution. So, yeah, I don't get it. But I should definitely delve further into that. I mean, here, I guess it's something pretty good. It's light rays. See, but it's always rays, and then the electrons moving out, and then the rays are in waves. But if you just had photon particles or a photonic beam, one photonic beam, not of the wave, because of course the wave is basically the energy. Of course, the wave is basically the energy. The wave is basically their lambda, their infinity, and they're saying that, well, it just uh, the ray becomes the wave. And that doesn't make any sense. It makes sense to some degree, but it just isn't the best theory, because all they're doing is, like I said, 1 light year, 2 light year, 3 light year, 4 light year. Just is pretty silly. So yeah, there can be an exchange of electrons. I mean, there should be the exchange of electrons anywhere, right? But why, again, why does the light source have to be quantized? So maybe that we will never know, or maybe it is just a racket, a Big Bang racket. Um, all right, so I find it confusing. So what should I know about it? Concept plus equations. What really confuses me is the equation K max equals HF. Is that like wave frequency minus pi or phi? I'm not going to know exactly what you're confused about. The photoelectric effect is quite simple for MCAT testing. Remember the equation E equals HF. H is the Planck constant. Yeah, that's like the basically their wave. And F is the frequency of the electron emitted. The frequency, see, this is what I don't get. How do they quantize that? F is the frequency of the electron emitted. However, you may be given the wavelength and properly substitute that in using C equals lambda. And lambda is their big boy, their big daddy wave, multiplied by the frequency. E is the kinetic energy of the electron emitted. For the equation, E equals HF minus phi. This is simply an extension of what is described above. Phi is the work of the function. Yeah, it's all relatively the same. The work needed for an electron to be emitted. Therefore, the equation better describes the net energy. The energy of the emitted photons minus the energy needed to remove the electron. Where does this like how are you supposed to figure any of this stuff out? I mean, obviously, you're if you give numbers, if you give like coherence, but yeah, it just is ridiculous. Again, E is energy, specifically kinetic energy, so 1/2 mv squared can be used. Let's see if I can even view this thing. So here it is. Okay. So yeah, it's always going to be kinetic energy. It's just it turns everything in infinite. And I don't mind everything being infinite so long as they don't have to have the speed of light. The photoelectric effect means that when you shine light that's at or above a certain frequency called the threshold frequency onto a metal, the photons of light are able to eject electrons from the surface of the metal. So why isn't that happening the whole time in their little ray? How do they describe that momentum? Because I think it should have the same effect. I think it should have the same effect. I mean, when photons hit more electrons, the ray should be weaker. When photons hit less electrons, the photon should be stronger, like out in space. Except I don't believe that it should be a ray. I just believe it should be made up of photonic bits. Um, I just think it's a little. I just think it's a little ridiculous that. I mean, if you play this game with atoms, why can't you play this game with photons? Since you're never quantizing atoms, you only quantize photons, and you just say photons have a bigger mass than atoms. Therefore, we're quantizing it, and therefore we can put a speed on it, and therefore we can have a Big Bang. I mean, I would never say there's a fucking Big Bang. It's insane. So stupid. The equation you give, the equation you gave is for finding the maximum kinetic energy of an ejected electron. Okay. It's actually a pretty intuitive equation. The wave frequency, or the HF, or the Planck constant frequency comes from an equation for finding the energy of a photon. E equals HF. You are subtracting from that the work function, which is the minimum amount of energy, which is phi, the minimum amount of energy that the photon had to use in order to eject the electron. It makes sense that this is the maximum possible energy that the ejected electron can get from the photon. Yeah, that makes sense. I mean, it's just kinetic energy again. I also need some help regarding photoelectric effect. Can you please help me understand a particular thing? Continue this thread. That wasn't very helpful. Thank you for your help. For phi, do you think conceptually all we need to know is that it is the minimum energy to eject the electron, or would we calculate it? I'm not sure how that is calculated. Yeah, this guy's struggling. I would be struggling too. I don't even think this is right intuitively. Um, I just don't like yeah, my plight is with the photon having speed. That's ridiculous. I mean, is it even light if it's just one photon? That's my point. Like, is it even an atom if it's just one electron? Like, all of this is quantizable, but just, well, I should say, all of this is like animation. But yeah, the fact that they do this shit with a Big Bang is crazy. Just completely turn it into a cosmic religion. So I think the phi thing is confusing. I'm using Kaplan, and they just call it the work function. The equation for the work function is W equals H threshold frequency, which is the exact same thing as E equals HF, except the threshold frequency is the minimum frequency of light needed to eject electrons. I believe the threshold frequency would be provided to you on the test. Yeah. Huh. Let's see if there's anything else. MCAT. Ask physics. We'll go with ask physics. In the photoelectric effect, does the time to reach the stopping potential decrease if the intensity of the light increases? Assuming that the frequency of the light is above the threshold frequency. I'm a little bit distracted right now. In the photoelectric effect, does the time to reach the stopping potential decrease if the intensity of the light increases? Does the time to reach the stopping potential decrease the intensity of the light? Is that a complete sentence? If the intensity of the light increases, okay, the stopping potential. So basically, are more electrons going to be emitted if the intensity of the light increases? Theoretically, yes. Like there'll be more reflection, and the reflection is theoretically uh, supposed to be the electrons. If I don't stand corrected, assuming that the frequency of the light is above the threshold frequency. So the threshold frequency again is the work function, and the work function should be of the electrons, like depending how thick or thin the metal is. But really, we know that atoms and electricity and the magnetism is happening everywhere. Well, theoretically, that works. Again, so it doesn't really make sense. And it doesn't. In that case, it doesn't make sense to have a speed of light either. So I'll go through some more of this. I mean, I'm not going to find any proof that there is a speed of light. I can check. Yeah, it's just not giving me much. I mean, proof of speed of light first discovered that there was finite speed in the 1600s, and now, yeah, we're up to 300,000. I mean, will it ever get to 300,000? Will it ever break its record? And this isn't a vacuum, and it doesn't get proven, it gets validated. And so, obviously, if there is atoms in the way, the light will be slower. Um, But again, I mean, 250,000 miles per hour. I mean, if we can't see that with our own eyes, then how are we supposed to understand it at, I guess, a mechanical level? Is my point, which we can't, which we've never consistently did with, which we've never consistently done with atoms, in trying to learn about refraction and diffraction in the microscope. So at CERN, but so it doesn't make any sense. Where was I? Okay. All right. Small thread. Electromagnetic waves induce electric currents. Electromagnetic waves induce electric currents. What might gravitational waves induce? Well, these are just different questions. What might gravitational waves induce? I mean, that's not a good question. I guess this wasn't a big discussion. Yeah, that's not very good. Maybe I should use Quora. But yeah, yeah, there's nothing